Hello again, and everybody take a breath. I promise this will be my last video for week 4. These are important concepts, so I want to make sure that people get a good foundation, get a good introduction to what they're looking at. So let's jump right into standard deviation and variance. If you go to your textbook and you look at the person, you've got 6 people in a distribution here. 6 people took an IQ test. And it looks like among these 6 people, you had a score of 110, 120, 100, 90, 130, 110. If you do our math, which is, adding all these together and then dividing them by 6, you'll come out with, our book is telling us, an average IQ of 110. Okay, so the mean in this case, if I were going to draw this, the mean is 110. The average is 110. So if we're dealing with standard deviation, which we will do a lot, standard deviation is the most commonly used measure of dispersion. And when I say dispersion, the standard deviation is basically giving you the average spread outness of a distribution. So remember, we have a distribution of scores. Hopefully those are in somewhat of a bell shape. But then if we took the distance from the mean from each one of those scores, like each score, we tried to figure out how far it was away from the mean, and then we average those together, that's the standard deviation. What is the average deviation away from the mean? So you're getting another average score. So it's using the average score that then determine another average, like another average of how far each score is away from the average score, which is a lot of averages. But again, like I said, we're going to use that term a lot, and those calculations a lot. So if we go to our textbook, and here's the example from table 3.1. And so what they try to do here is that they try to subtract, because anytime you're trying to find a difference between scores, you want to have a subtraction. So score 1 is 110. So if you were to subtract the mean from 110, oh, that is the mean, so you get a score of 0. Then you also have 120. So if you take 120 minus 110, you come out with a score of 10. So it's 10 points away. And then if you look at 100, in this case, I said earlier 100 is an average IQ, but in this case, these 6 people, the average IQ is 110. So if you subtract 100 from 110, you get -10. Another person, participant number 4, scored a 90. That was 20 points below the mean. You have another person who scored a 130. That's 20 points above the mean. And then you have another person who scored exactly on the mean. So what happens is if you add all these things together, you add 0 to 10, because I'm trying now, right? We've got to figure out an average, right? So most times when we figure out an average, we add the scores and then divide by the number of scores. So we got 1, 2, 3, 4, 5, 6 scores. But here we go 10 minus, okay, there's 0, but 10 minus 10 is 0. Okay, so now we're down to -20, but now we add 20, so that's 0, and here's 0. And you're like, wait, I came out with 0. So if I divide a 0 by 6, that's still 0. So you're left with, okay, how do I figure out standard deviation? The way that we do this is mathematical conversion. So we take a squared deviation. So we square all the scores, because what happens when you square something? If you had 2, let's say you had -2. If you had -2 and you take the square, the square root, that's 2 times it, -2 times itself is what? It's a positive. Anytime you square something, you are able to remove the negative number. So -10 times -10 is 100. Oh, I see. So when we square something, we remove the negative so we can actually add it and make sense of it. So we're mathematically converting these scores, the deviation scores, and we're taking a square deviation so we can compute the standard deviation. We have to do this. We have to convert this mathematically for us to even be able to run this. So you'll see that we have 100, 100, 400, 400. And so then, so if we take the sum of squares, we come up with 660. If you add all those together, excuse me, the sum of x, all right, sum of squares equals, sorry, it equals 1,000. So you take sum of squares equals 1,000. So you come up with 100 plus 100 is 200, and then 400 plus 400 is 1,000. And then you take that by the mean, and then you get excuse me, the variance. So the variance is always, let's go back down to variance. The variance is always going to need to be transformed by figuring out square root. And so the variance score is actually really close to the standard deviation. The variance score is this raw calculation where you still have the sum of squares, where you still have these squared numbers, and so the number is inflated. So that will give you the variance. But then if you take the square root of the variance, that's where you come up with the standard deviation. And so that's where the numbers convert back to, and you can make sense of how far each score on average falls from the mean. The standard deviation in a nutshell, if I can give this to you, the standard deviation in a nutshell is the average spread outness of the scores. I know that doesn't seem like it's a textbook answer, but that's honestly how I made sense of it. The average spread outness. Dispersion can be, yeah, things are dispersed everywhere, but I think of a scatter plot when I think of dispersion. If I think of average spread outness, I'm thinking, okay, this score is if we take the sum of all these scores and we figure out, the mean of all those scores and how far each one on average falls away from that mean, that's your standard deviation. It's an important number because it helps you determine later on your significance and whether or not you have significance in your research. So remember that thought. If I was confusing, reach out to me. I'll find another video that's clearer than I am. But anyway, I hope that you found this beneficial. I will be reading over your assignments for the following week and get them back to you as soon as I can. Take care, everybody.